Okay, I'll start recording. Yeah. So about numbers, if you remember the first thing that we studied, right, about numbers, real number, imaginary number, then real number is broken down into, tell me, fractional, rational number, irrational number, right? Then rational number is broken down into, tell me, integers and fractions, right? Then integers are further broken down into negative number and non-negative number. Non-negative number is broken down into, right? So I'll just make one chart again, right? So I can say that first was numbers. Okay, totally numbers. Numbers was broken down into two parts, right? Real and imaginary. Real and imaginary. Right, everyone? Then real number is divided into again two parts, which was rational and irrational. Right? Then again rational was divided into two parts, which is, tell me, integers, or I'll just write it, fractions over here. So fractions and decimal, fraction and decimal are almost the same category. Then we have integers. Now integers are further divided into, right? Integers are further divided into non-negative integers, non-negative or negative integers. Negative integers
and whole numbers.
Right? Negative integers and non-negative integers. Non-negative. I'm saying non-negative, I'm not saying positive, right? Non-negative. And non-negative is further divided into, tell me, whole number, and natural number. Right, everyone? Remember? Yes, very good. See, why non-negative? Because zero also, right? Zero is not a positive number, it's not a negative number also. So zero is called as non-negative. Instead of positive number, zero is called as non-negative. Okay, Ragini? Right? Okay. So this is not the end. This is not the end, right? Natural number. Natural number is again further divided into, right? Prime number. Again, there are many divisions, right? Then co-prime number. Okay, there are many other divisions, right? And again, yeah, composite number also, you can just say composite number, consecutive number, right? Okay, so we will study till this. So I guess I need not to tell you about these numbers. Everyone know about these numbers. What is rational number, what is irrational number, right? So I'll just say rational number are the numbers which can be written in form of p by q, and q should not be equal to 0, right? That is a rational number. Okay, now fractions or decimals, right? Fractions or decimals are basically the numbers, right, which are part of some other, right? Yes, part of some other number which is p by q, and q should not be equal to 1, right? Q should not be equal to 1, because if q is equal to 1, it will be integer, right, everyone? Right? Okay, now apart from that, we know everything, right? Apart from that, we know everything. So that is the first, if you talk about the chapter, that is the first concept, which is the introduction of numbers. Introduction of numbers, right, everyone? Now, when you talk about, yes, okay. No issues. You can just divide non-negative also. Okay, non-negative is whole natural. Okay, right? So if you see this, right? So tell me, what are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? They are natural number, Integers, whole number, all of the above. Tell me. So answer is already ticked, but I hope all of you could have said that it is all of the above. It is whole number also, it is integer also, it is natural number also. Right, everyone? Right? Okay. So second topic was representation of integers on, say, real number are the number that we can count. Okay, real number are the numbers that we can count, or basically that we usually study. Imaginary numbers are the numbers which does not exist. Okay, it is imaginary. So Arav, you need not to worry about imaginary numbers for now. Okay, okay, right. So the second concept was imaginary numbers. Sorry, number line. I hope all of you remember number line. Yes. Shavya, for now we will focus on the syllabus that is coming in test. So imagine number we will complete after syllabus is completed. Okay, don't worry about that. Okay, so see this, right? A number line is a line in which all the integers are plotted, right? So we have 0 at the middle, right? We have 0 as a middle number, right? On the right hand side of 0, we will have positive numbers, right? Positive numbers. And on the left side of the 0 we will have negative numbers. Okay, so this is your number line, right, everyone? Okay, so number line is a line which represents all the real numbers. Tell me, yes or no? Number line is a line which will represent all position of all the real numbers. All the real numbers I'm saying, not integers. Now, can you say what is the position of 3.5 here? Right, tell me. 3.5, can you say? Yes, very good. It should be between 3 and 4, right? 3.5. Got it? Yes. Very good, everyone. Okay, so that is one concept that we will focus on. So I can say that, right? This one, tell me. In this one, right? Okay, this is, yeah. What is this one is, yeah. The next concept is recall. Again, recall of what we have studied in junior classes. Yes, very good. Exactly between 3 and 4. So we know since junior classes, we remember the concept of operators, right, everyone? I hope everyone remember, right? Concept of operator. Okay, right? Or various mathematical operations, right? Recall. So this was the other important topic, various mathematical operations, right? Operations, right? Okay, so what are they? The first was addition. So when you talk about addition, then positive plus positive, right? Positive number plus positive number, right? Will give you positive number. Yes or no? Yes or no? Yes, very good, right? Negative number plus negative number, right? Will give you negative number, right, everyone? Right? So both are addition, remember this, both are addition, right? So if we have two number of the same sign, we will add them, right? Number of same sign will be added, be it positive or negative, right? Okay, then the second was subtraction. Okay, so again, right, subtraction is basically the addition of opposite signs, right, everyone? Right, subtraction is basically the addition of two numbers having opposite sign, as simple as that. So positive number, right, minus positive number, right? Okay, now what would be the sign? Tell me. The sign will be what will be the sign? Sign will be bigger number, bigger number. Okay, the sign will be of bigger number. For example, 7 minus 9, then it is minus 2. Okay, but if we will have 9 minus 7, then it will be plus 2. Got it, everyone? This is the concept that we remember. Okay, everyone? Yes? Okay. Then again, minus, minus, minus. Again, the sign will be of bigger number. Bigger number. Right? Now, this can also be written as, plus, plus, minus. Right? Because minus, plus or plus, minus. It can be written like this. Or this can also be written as minus, plus, plus. Right? Okay, that we will see in next concept, which is multiplication. Okay, multiplication. Sorry. Now multiplication is very important, right? Multiplication is very important because when you talk about multiplication, okay, we have to think what is the sign. So we know that plus into plus, right? See, process will be of multiplication. I'm talking about sign. Sign will be of plus. Plus into minus, sign will be of minus. Plus, sorry, minus into minus, sign will be of plus, and minus into plus, sign will be of minus. Got it, everyone? Okay, very basic. Now then we know that bracket, the meaning of bracket, right? The meaning of bracket is also multiply, right? Is also multiply. And the meaning of is also multiply. Okay, it means 1 by 3 of 6. What does it mean? It means 1 by 3 into 6. Okay, everyone? Or 1 by 3 bracket 6 minus 2, right? So it will mean what? 1 by 3 into, now 6 minus 2 is 4. 4. Got it? Right, everyone? Agree? Agree? Then after multiplication, we studied the next property, which was division. Okay, right? Division. Now division same as multiplication, sign is same as multiplication in sign convention. Now one thing that we should know about division is a divided by b, right? A divided by b can be written as a into 1 by b. This is one important concept that we should remember, right, everyone? Right? A divided by b, it means a is divided by b, which can be written as a into 1 by b. Okay, right, everyone? Now, including all those concepts, we have studied something called board mass in junior classes, right? Where b means bracket, o means of, right? D means division, M means multiplication, A addition, and S subtraction, right? So we have solved problems also based on this. So what is the meaning of this? This is the order that should be followed, right? This is the order that should be followed to solve any, yes, right? Yes, yes, yes. So obviously we have to follow this order only when it is present, right? So generally O is not present, right? Generally O is not present. I'll just give one example, right? Just see one example. 3 minus 4 bracket 6 minus 3 divided by 2, right, plus 6 into 2. Now in this case, right, in this case, first bracket work will be done. So 3 minus 4. Now bracket 6 minus 3 is 4, right? So bracket means into 4. Now this is divided by 2. Okay, right? Plus 6 into 2. Now this can be written as 3 minus 4 into 4. Now this division can be converted into 1 by 2, right? Always do that. Okay. Oh, sorry. Yeah, my bad. 3 3. My bad, yeah. So always convert like this, plus 6 into 2. Now multiplication job will be done, right? So 2 will divide this 4 2 times. So we'll get 3 minus 2 into 3, 6, plus 6 into 2, 12. Now addition work, 3 plus 12 will be added, right? So we will get 15 minus 6. Now 15 and 6 will be subtracted, so we will get 9. So the answer would be 9. Okay, everyone, right? Yeah, Ragni, I corrected it. Okay, got it? Tell me. So these things we have already studied. I hope everyone know these things. Okay. Then after this, we studied about the properties, right? What are the properties? The first property was closure property. Okay, properties. We have spent enough time in this. Okay, so I'll just write. First was closure property, right? Yes, closure property. What was closure property? Tell me. What was closure property? Tell me, anyone? Closure property? Yes, very good. So closure property means if A is integer plus B is integer, right? So the sum is C. Now C should also be integer, right, everyone? Okay, yes. So I can say that addition follow closure property, yes or no? Addition follow closure property? You should say, sir, your statement is wrong, right? You should say in addition of integer follow closure property, right, everyone? Right? Addition of what? Addition of integer follow closure property. Okay, right? Right, everyone? Now, second was which property? Tell me. Second what was which property? Commutative, yes. Right? So when you talk about closure property, so it is closure under addition, closure under subtraction, closure under multiplication, closure under division, right? So for integers, for fractions. Now second is commutative. Commutative. So what is commutative property? Commutative property says if A plus B is equal to B plus A, right? Then it is commutative. Then A and B is commutative over addition. Okay, everyone, right? Or if A into B is equal to B into A. So multiplication is also commutative over, right? Multiplication is also commutative. But can I say that A minus B is equal to B minus A? Tell me. This is commutative, this is commutative. But can I say this? No, right? No. So subtraction is not commutative. And can we say the same thing about division? A by B is equal to B by A? No, right? So division also not commutative. Okay, everyone? Tell me. Okay, got it. So everyone got this? Very good. Now after commutative, we had associative property. Third one was associative property. What was associative property? So A plus B plus C can be written as A plus B plus C, right? Or A into B into C can be written as A into B into C, right, everyone? Vishka, that is wrong, right? A into B plus C cannot be written as A plus B into C, right? See, because this is wrong. It is AB plus AC, and this would be AC plus BC, right? So this is wrong. Okay. Okay. The next is distributive property, right? Next is distributive property. So this is the example of distributive property. So A into B plus C can be written as A into B plus A into C. This is your distributive property, right? Okay. Yes, this is a distributive property. Now after this we have what? After this we have, tell me, additive identity, right? Additive identity. What is additive identity? It is always zero. It is always zero, right? Okay. Yes. So A plus 0 is equal to A. So it is additive in identity, always 0. 6 is additive inverse, right? Additive inverse. So what is additive inverse? Minus of that number, right? So A plus of minus A will give 0. So any number which is added to that number is your 0. Yes, very good. Negative of a number is your additive inverse. Remember this. Then we had, tell me, then we had multiplicative identity. Yes, multiplicative identity, which is basically 1, as A into 1 is also A. So this is your multiplicative identity. Plus 1, Daksh, it is not minus 1, plus 1. Okay. Now then we have multiplicative inverse. Do not get confused between inverse and identity. Okay, inverse means it should be 1, right, or 0. 1 in case of multiplication, 0 in case of addition. So multiplicative inverse is reciprocal of any number, which means A into 1 by A is equal to 1. So 1 by A is the multiplicative inverse of A. Okay, everyone, tell me. Okay, right? Okay, very good. So now after this, right, after this, we studied about, tell me, fractions. In integers, we studied only these things, yes or no? In integers, we studied about these things only. Anyone have any issues? Tell me yes, right? Right, everyone? So let's see. Okay. So these are the topics, right? Yes. So we have studied these properties of integers: closure property, commutative property, associative property, right? Distributive property, then additive identity, multiplicative identity, then additive inverse, multiplicative inverse. Okay, so I'll just share this with you, okay, that you can just go through once. Okay, everyone, right? Everyone, so very basic questions, right? Yes, Shravya, you have to write. Yes, you have to write with the bracket. Okay, you have to write with the bracket. Okay. Srijan, if you have studied, it will be easy, right? Because see, always remember this. Questions are not hard. It's the answer that is hard, right? Questions will always be easy, right? Okay. Okay, everyone. So let's go to second chapter. Okay. The second chapter was fractions and decimals, right? I hope all of you remember fractions and decimals. So we will just go through rational numbers, because rational number will consist of all the, tell me, rational number will have all the concepts of fractions and decimals, right, everyone? Okay, just see the concept of rational numbers. Everyone, please mute yourself. Okay, now when we see the concept of rational numbers, so it will consist of the concept of integers as well as fractions and decimals. Yes, Sanjay, yes, Purvi, right? It will consist of both the concept. That's why I'm just doing rational number. Okay, now when we talk about rational number was what? Rational number was a number, right? Which consists of a number in the form of P by Q, right? Where Q should not be equal to 0, right? So basically rational number, yes. So basically rational number consists of both fractions and integers, right? So if you study rational number, you are studying both fractions and decimals as well as integers. Okay, so that's why I am covering this, right? Now, when we talk about properties of rational number, so it includes, right? So first of all, it should have the same properties as integer, yes or no? Same properties as integers, because we will study the same thing. Okay, right? Okay, so the first property that we studied was closure property. So when we see this closure property, right? So when we talk about rational number, obviously we have lots of parts, which is whole number, integers, then fractions. Now, first we'll talk about whole number because it will cover your fractions and integers, sorry, fractions and decimals as well as integers. Now tell me, whole number, right? Now we have operation, we have 4 operations. As you can see, we have 4 operations. What do you think? Will whole number obey closure property over addition? Yes or no? Just tell me yes or no. Yes, very good. So whole number are closed under addition. What about subtraction? What about subtraction? No, exactly. Nothing, right? Nothing will be closed under subtraction, neither whole number or integers or fraction. Nothing will be closed under subtraction. That you should remember, right? Multiplication, yes, right? Division, no. So you should remember, usually, right? Multiplication and addition will be closed for all the numbers. Okay, now this was first number, whole number. Then integers, obviously if something is following whole number, it should follow integer also, right everyone? Yes or no? It should follow integer also. So obviously integers are also closed under addition, right? Okay, as well as multiplication. But subtraction is also closed under sub integers, yes or no? Subtraction is also closed under integers. Right? Integers, because obviously if it is negative or positive, it will be integers. Okay, right? Now what about multiplication? So yes, multiplication will be closed, right? But addition, sorry, subdivision will not be closed. For example, right, when you talk about division, it will become fraction. Yes everyone, it might become fraction. Okay, right? Now, what do you think about rational numbers? So when you talk about rational numbers, considers fractions. Rational number, what do you think? Right? Rational number are the numbers which can be written in the form of p by q, which is basically a fraction, okay, or decimal. Any number is your rational number if it can be written in form of p by q. So fraction is your rational number, right, everyone? Okay. Now, when we talk about the properties or addition, subtraction of a rational number, we will follow the same procedure. Right? So, what are the procedures? Let's see. Right? First, addition of rational number or addition of fraction. You can just say that addition of fraction also. Okay, right? Addition of fraction, addition and subtraction of fraction. Okay. Now, when we talk about addition and subtraction, Yes, yes, Shravya, right? Division follow closure property in rational number now, because again, even if it's a fraction, it is a rational number. Yes or no, right? Okay. So when we talk about addition, subtraction, fraction number, right? What should we do? Suppose we have 1 by 6 plus 1 by 5, right? So the first step is step 1. Step 1, take the LCM of denominator, right? LCM of denominator. Okay, everyone, right? Except for a divided by 0, Ragini, except for a divided by 0. Okay, so as we studied in last class now, right? It follows under closure except for this. If you include this, then it will not. Okay, so the LCM is 30, right? 30. Now step 2. Step 2. Divide the LCM with respective denominators. Divide the LCM with respective denominator, right? And multiply the numerator with the quotient. With the quotient. Okay, so 30 divided by 6, 5. So it will be 5 into 1 plus 30 divided by 5, 6. So it will be 6 into 1. Right, now just add the numerators, right? So we will get 11 by 30. Okay, everyone, right? So these are the two steps for addition or subtraction. The sign should be there. Okay, right? Now next is multiplication or division. Or division. Now, when we talk about multiplication or division, right, we should follow one basic rule. Okay, one basic rule. When we are multiplying, so if we have A by B multiplied by C by D, right? Step 1. Okay, step 1. Multiply numerator with numerator, right? Multiply numerator n1 with n2, numerator with numerator, and sorry, d2 denominator with denominator. As simple as that. Multiply A with C and B with D. So it will be AC by BD, right? As simple as that. Now, if it can cancel, you can cancel that, right? If it can be cancelled, you can cancel. Okay, you can divide. Yes, yes, that's what I'm saying. Okay, now if we have A by B divided by C by D, right? So first you can convert it into A by B into B by, sorry, D by C, right? And follow the same, Okay, everyone, tell me, right? For example, 3 by 6 divided by 12 by 5 can be written as 3 by 6 into. Now, when you talk about reciprocal, you should be like doing reciprocal of the second number. Okay, so it will be 5 by 12, right? So 3, 12, 4 times, so it will be 5 by 24. Okay, everyone, right? Okay, everyone, very good, right? Very good. Now, so this is the last thing, right, that Ragini asked. Okay, so rational number are not closed under division if you consider 0, right? If you don't consider 0, then it will be closed under division, right? That's what it is written. If you exclude 0, then it is closed under division. But if you are including 0, then it is not closed under division. Okay. So we have solved this also. We have solved this, right? Commutative property also we have solved, right, everyone? This is all the things are present in your Google Classroom, right? Okay, so we discussed these things now, right? This is what we are discussing, right? We know that whenever we have to add or subtract any number, take the LCM. right? Take the LCM of all the numbers, then step by step solve it. Okay, everyone, right? Srisharan, got it? Akshit, are you getting? Right? So rule of 0, rule of 1, right? Negative numbers, reciprocal, we have already covered. So is there any doubt between these? Tell me, any doubt between these? If not, then we can progress to next topic, right? Which is representation of rational number on number line. Okay, representation of rational number on number line. Now, when we talk about integers, so integers are easy to represent on number line, yes or no? Integers are easy to represent a number line. Yes. So what about rational numbers? So we have studied, right? We have studied that if we have rational number, right? If we have a rational number, I can say that, right? Rational number can be represented on number line by two simple ways. So, right? Suppose we have to represent 4 by 9, right? As well as 12 by 5. Okay, so how to do that? How to do that? How to represent it? Okay, represent it. Now think about this. Suppose when we talk about number line, right? First of all, make a number line. Agree? 0, 1, 2, 3 with integers 1. Okay, this you do draw. No issues in this, right? Now check this 4 by 9. 4 by 9. First step 1, as we said, right? Step 1. Check the numbers lying between which two integer. 4 by 9 lie between which two integer? Tell me. 4 by 9 lie between which two integer? 0 and 1. Exactly. Very good, everyone. 0 and 1. Right? Now, then second step. Step 2. Right? Divide. Yes, divide the number 0 to 1 into how many parts? 9 parts. Divide into D parts, right? Where D is the type, this, and yeah, this denominator. So 0 to 1 is divided into 9 parts. So 1, 2, 3, 4, 5, 6, 7, 8. Because if you draw 8 line, it will divide into 8 by 9 parts. So the first one, it is 0 by 8. I'll just expand it. Okay, I'll just expand it. You can just expand it, right? This is 0, this is 1. Okay, I'll just expand this area, right? I'll just expand this area. Okay, now 0, so this is 0 by 8. Then we have 1 by 8, sorry, 1 by 9, my bad. 1 by 9, 2 by 9, 3 by 9, 4 by 9, 5 by 9, 6 by 9, 7 by 9, 8 by 9, and this is 9 by 9. Got it, everyone? Tell me, got it? Right? Now, which number you have to plot? You have to plot 4 by 9. So 4 by 9 would be this number. 4 by 9 would be this number. Okay, everyone? So this is your 4 by 9. Got it? Akshit, Srisharan, got it? Harsh, Nandish? This is the concept that most of students made mistake, right? You should remember this. Now, what about 12 by 15? Tell me, sir, 12 by 5, tell me. What about 12 by 5? 12 by 5 lies between which two number? Yes, right? Very good, Esther. You also got 0 by 12 by 5. 12 by 5. See this. 12 by 5, right? Lies between 2 and 3, na? Right, everyone? Yes, very good. No, Shravi, you can represent by on two number lines or same number line depending on you. Don't worry about that, right? So 2 by 3. So I'll just expand this. I'll just expand this. Okay, expand this. This is how you should show in the exam, right? So 2 by 3, right? Expand this. 2, 3. Okay, now it is divided into how many parts? 5 parts. So this is what? 2 by 5, right? This is, now forget about 2, right? This is 2 plus 1, 3 by 5. Sorry. Wait. This is 2 now. Okay, okay. Sorry. So divide into 5 parts. Right? So this is 10 by 5. 10 by 5. 2 is 10 by 5. Nah, this is 10 by 5. Then we have 11 by 5. Then we have 12 by 5. Then we have 13 by 5. Then we have 14 by 5. And then this is 15 by 5. Right? Got it, everyone? 2 by 5 is basically 10 by 5. 2 by 5 is 10 by 5. Yes or no? 2 is 10 by 5 now. Right, everyone? Right? So 12 by 5 is this number. 12 by 5 is this one. Okay? Got it? Everyone got this? Tavishka, Esther, Yukti, Rishika, Amisha, Harsh, Nandish. Okay. Very good, everyone. Right? Very good. So we are completing our fraction also like this. Okay. Right? Because if you have to represent fraction, then also you would do the same thing. Right, everyone? Okay. Now, rational number between two rational numbers. I hope all of you remember. Still, we will discuss. Okay. Yes, yes, yes. It should be same, right? Here, I am very bad at drawing. That's why. Okay. Now, so second, next topic was rational number between two rational number. Rational numbers between two rational numbers. Okay. Now, let's see this. Let's say we have 2 by 5 and 3 by 4, right? We have to find uh, first only if you have to find only one rational number between them. Number between these two, right? So what you should do, so suppose this is A, suppose this is B. So the only one rational number between these two, exactly between, if you talk about exactly between, then C would be A plus B by 2, right? Exactly between. Yes or no? A plus B by 2, right? Okay. So which is what? Which is 2 by 5 plus 3 by 4 by 2. Now you know how to add these two, right? Take the LCM. So 5, 4 LCM is 20. Then 5 divided by 24, 4 into 2, right? Plus 20 divided by 4, 5, 5 into 3. Now this is whole divided by 22. So it will become what? So 20 will go down. So it will become 40. Now this will become 8 and this will become 15, right? So it will become what? 23 by 40. Okay. Now step 2. Right? More than one rational number. More than one rational number. Right? Then again, step 1. Step 1. Take the LCM. Right? Of A and B. Of A and B. So the LCM of, I'll just take another example. 1 by 3 and 2 by 5. Right? I'll take another example. Okay, everyone? No, Manita, because you should get more time for self-study, right? So it's not that we have a 2-hour class or 1.5 hour class. Like whenever your doubt is completed, we will end the class so that you can get at least 2-3 hours. Okay, right? 2 won't go up. 2 is in denominator, right? 20 will go down because see, this is the main fraction. This is the main fraction. This is, see, I'll just show you this also, right? P by Q divided by, right? Suppose divide by A. This is equal to P by QA. Okay, right? Whereas P by Q divided by A by B, this is equal to P by Q into, right? This divide, so into B by A. Got it? Right, Ragini? Okay. Okay. Right. So that's why A and Q are multiplied. Now, see this. Now, 1 by 3 and 2 by 5. So LCM of 3 and 5 is 15, right? 15. So you have to make the denominator 15 of both the numbers. Okay, right? Step 2, right? So 1 by 3 can be converted into, this 3 can be converted to 15 by multiplying 5 by 5, right? So number will become 5 by 15. Okay, right everyone? Tell me now. In the same way, 2 by 5, okay, 2 by 5, right, can be converted into 15 by multiplying, tell me, 3 by 3, which is 6 by 15. Now see this, these two are close number, 5 6, right? There's no other number which is between 5 and 6. So multiply again by what number, right? Multiply again by 10. Why 10? Because even if you multiply by 2, it will have only one number in between, right? Multiply by 10. You can multiply by any number, by the way, but you should multiply with the same number. So it will become what? 50 by 15, 150, and this will become 60 by 150. Now tell me, how many numbers can we have between these two? We can have 9 numbers, right? Which is 51 by 150, okay, 52 by 150, and so on till 60 by 150. Okay, right everyone? Devika, don't worry, compound fractions will not be coming in the examination. Okay, compound fraction will not be coming in the examination, right? Okay. Yes, yes, Shravya. Right? So I hope all of you got this concept. Yes or no? Tell me. All of you got this concept? How to add rational numbers between more rational numbers? Yes or no? Yes or no? Tell me. Everyone got this? Sricharan, Esther, Yukti, Akshit, Manta, Mansa, Aditya. Aditya, you are here, right? I guess you are logging from your father's number. Madhur, yes. Rishika, Misha. Okay, very good, Tavishka. Okay, so this is the end of rational numbers, fractions, and integers, right? So I hope only these concepts are covered. Yes or no, right? Yes. Is there any other concepts that you find difficult in these 3 chapters? Tell me. No? Very good, everyone. Very good. Right? Okay. Now, next, which chapter you want me to revise? Tell me. Next, which chapter? I guess data handling is not required, right? All of you remember data handling? Okay. So simple equations, right? Simple equations. Okay. Right. So we will discuss simple equations, right? Then after simple equations, right? Someone said profit and loss, right? Because we have less time, so obviously I cannot revise all the chapters. So we will be revising the important chapters. Okay. Yes. Others are easy. Now, as I told you, you should focus on, right? Triangles and congruence you should revise, because you know how to solve it, but you don't know how to write it. Okay, so please see the detailed solution of the test that we have taken, right? And self-evaluate, guys. Everyone, please self-evaluate, right? And message me your scores. Okay, message me your scores of both congruency as well as rational numbers. Okay, if you message me your scores, right, then only I'll just check and return to you guys. Okay. Yes, yes, 1 to 9 are coming. Okay, 1 to 9. 9 was rational number, no? Right? Okay, let's see simple equations. Okay, everyone, let's see simple equations. See, if you see this, right, how much we studied simple equations for more than 1.5 months, right, everyone? See how many exercise, how many books we have solved. Yeah. I'm returning it one by one. Okay, because see, frankly speaking, geometry wise, congruency, I was checking everyone's paper, but it is very hard. Now, when we talk about the concepts covered in simple equations, right? Now, the first concepts, when we talk about the concepts, so we will use the concept of rational number. Second, we should know what are the variables, right? So if we want to, okay, if we want to if we want to solve any problem, because again in this problem, in this chapter, we just have to solve, right? So we will see how to solve, steps to solve any linear equation. Okay everyone, right? So let's see steps to solve linear equation. Okay, now it depends on the type of linear equation. So I will start with the difficult one, because easy one you can solve anyways, right? Now, if we remember, basically when we talk about linear equation, we have two steps which is very important, right? First is transpose, trans, transposing, right? And second is cross multiplication, cross multiplication, right? So what are the things that we should remember? Yes, in these, when we talk about transpose, sign will change, sign will change on transposing to the other side of equality, to other side of equality, right? Means positive will become negative, negative will become positive, multiply will become divide, and divide will become multiply. Got it everyone, right? Yes. And second, right, cross multiply is only done when we have a by b is equal to c by d, right? Only then if you have a plus b by c is equal to c, d by e, right, we will not cross multiply. Okay everyone, right? These are the two rules that you should follow, right? Now when we talk about the steps, right, let's see, right? Okay, now let's see one problem, right? Let's see one example. The example that I'm taking over here is, again, take the difficult one from your textbook only. Okay, take the difficult one, the most difficult one, right? We have discussed this, we have discussed everything, so please revise everything. Okay, we have discussed all the exercise. Okay, it's not here, so let's see this one. Yeah, this one. This chapter 2 consists of difficult problems, right everyone? Wait, where is chapter 2? Wait, I can't find. Wait. Okay, I'll just give one question from there. Okay, I'll just take some random question, right? Let's see. Okay, let's see. So we have 2x by 3 plus 4 into x minus 2 divided by 3, sorry, divided by 5 is equal to 2x plus 5 minus 3x by 6. Okay, everyone, this is complex enough, right? Tell me, this is complex enough? Okay, so here we have two methods, right? Let's see. Here we have two methods. Okay, the first method is, right? First method is do transpose first, then cross multiply, then cross multiply. And this, right? Cross multiply first, then transpose. Yes, LCM we will take, right? I'm just talking about the mean. Okay, right? The mean difference. Okay, the mean difference. Got it, everyone? Right? Okay, depends on type of question, Devika, right? So let's see, this is first method, this is second method. Let's go first method. You will decide by yourself what is your easier one. So the first method, as I said, the first method, right, is what? Transpose first, right? So before transposing, right, you have to write everything in, tell me, you have to write everything in standard form. Okay, split everything, first step, split everything, every term, split every term. Okay, so 2x by 3 plus 4x by 5 minus 8 by 5 is equal to 2x plus 5 by 6 minus 3x by 3. Got it? Tell me, got this step? Got this step? Yes or no? Yes or no? Everyone, Akshit, Arav is not here, I guess. Daksh, Yukti, Esther, because many students made this mistake, right? This is first approach. Then second step, right? Transpose. Pose all variable terms to one side, and right, so 2x 4x is this side, so this, I'll just change the pen. Okay, yeah, so this will be transposed this side. Okay, this will be transposed this side. Now this will be transposed this side, and this will be also transposed this side. Agree, everyone? Agree? Right? So after transposing, we will get something like this: 2x by 3 plus 4x by 5. Now plus 2x will become minus 2x, right? Minus 3x by 5 will become plus 3x by 6 is equal to, this is 5 by 6. Now minus 8 by 5 will become plus 8 by 5. Got it, everyone? Tell me, everyone got till this step? Everyone, Esther, are you getting? Harsh, Nandish, step by step, right? Very good. Now, then we will take LCM. Now we will take LCM. Take LCM. See the difference, right? I hope all of you see the difference, right? I hope all of you see the difference now, right? We will see the second approach also. Now, take the LCM of everything all together. It will be easy. So it is 3516. What is the LCM of 3516? What is the LCM of all the four numbers? 3516. If you see, the LCM of 3516 is 30 only. Yes, very good. Right? LCM of 3516 is 30 only. Yes or no? Yes or no? Yes, very good. Now 30 divided by 3, 10. So it will be 10 into 2x. 2x plus 30 divided by 5, 6. So it will be 6 into 4x minus, because it's minus 1 divided 30 divided by 1, 30. 30 into 2x plus 30 divided by 6, 5. 5 into 3x. Right, everyone? Is equal to, now this is 5 and 6. LCM of 5 and 6 is also 30. Now this is 5 into 5 plus 8 into 6. Agree, everyone? Tell me, agree? Anyone have any doubt till this point? Now, can I write like this? Can I write like this? This is basically 20x plus 24x minus 60x plus 15x, right, by 30 is equal to 63, right? Right, everyone? By 30. Agree? Agree? Anyone have any doubt till this point? Now, since it is 30-30, so after cross multiplication, it will be cancelled, right? It will be cancelled. Yes, very good. So it will become easy, much easier now. 20 plus 24, 20 plus 24, tell me, 44 plus 15 is 59. So we will get what? 59x minus 60x is equal to 63. So minus x is equal to 63. So x will be minus 63. Yes or no? Yes or no? Yes, anyone have any other doubt? Tell me. So this was first approach. This was first approach. Okay, right? So this approach is, for me, I think this approach is easy, right? This approach is easier. Yes, you can verify it. Now, second approach. So second approach, let's see second approach. Or you should do by this approach only, it's fine. But again, you can, second approach, should I teach second approach? First take, second approach means first take LCM, then cross multiply, then transpose. Okay, right? Second approach is first take LCM, cross multiply, then transpose, opposite of what we did in this one. Okay, right? Yeah, you should follow one method only. This method is easy. Okay, right? And this removes confusion also, right, everyone? This removes confusion also. Okay, so you should follow this only. So now, apart from this, the only problem that you might have in linear equations is word problems, right, everyone? And frankly, there's only one solution of word problem. Try as many problems as you can, right? Word problems will not be solved, right? It will not, like, see, it's not chemistry or biology or social science. Not that once you remember, you got it. No, right? You have to develop your intuition. You have to solve as many problems as possible. Then see, for example, right? For example, when you are a kid, right? When someone is a kid, they don't know how to walk or how to talk, right, everyone? Right? But when they keep on doing it, right, over the period of time, they remember how to talk. Now, how, like, how many of you remember speaking when you're a kid? No one, right? Okay, just take about any language, be it Kannada or Tamil or Telugu or Hindi or English, right? You didn't know it, but as you keep on talking, as you keep on speaking, right, it got it in your intuition. Okay, like if a guy from some other place, right, suppose someone from Japan, right, he speaks in Japanese because it's that easy for him, because it is in his intuition, right? Now the same thing will happen to maths also, because some people ask me, sir, how can you know that we have to do this? Okay, right? Right, everyone? Right? But if I ask you, what is 100 plus 200? Tell me, what is this? Right? Now, tell me, do you have to think? Do you even have to think for this? Tell me, did you even have to think for this? No, but if you ask the same question from someone who is in grade nursery, right? Someone who you ask the same question who is in nursery, will he be able to solve this? No, right? That's the thing, right? When you keep on practicing, okay, especially the harder problems, do not shy away from harder problems, okay, right? Try to solve harder problems, because if you solve harder problems, your mind will be adjusted according to that. Then everything will become easy, right, everyone? For example, if anyone who would have followed what I have said from the day one, how many of you, right, feel that your class syllabus, whatever is being taught in school, right, and your normal school syllabus is easy now? How many of you are feeling this? Tell me, right? Is there anyone who is feeling that it is not easy now? How many of you like had any difficulty in understanding any chapter of like science in school, like be it heat? Like, don't you think that you know much more about heat than what normal students of your class, right? You know what is heat actually, you know lots of other things also, right? So that's the thing, okay, right? That's the thing. When you keep on doing harder problems, keep on trying harder, understanding harder concepts, right? It will be difficult at first, okay? Obviously, it will be difficult at first. Yes, Devika, very good, right? That's the thing, okay? Because see, some of you, because you were not habitual of that, right? When we gave the first test of linear equation, first hard test of linear equation, right? Most of you cried and like felt very sad. But just think about it now. Just think about it now. Will you find it very hard? Just think it now, right? How many you think that you have more confidence as compared to that test? Just raise your hand, right? if if you keep on solving, if you keep on practicing, you will gain confidence, okay, right? Okay, everyone, so this was linear equation. These are the concepts that you should remember to solve any problem in linear equation. If you know these concepts, then you can solve any problem of linear equation, be it difficult problem or easy problem, doesn't matter, you can solve. Okay, now after this, many are saying comparing quantities, profit and loss, right, everyone? Because we just completed comparing quantities now. So in comparing quantities, profit and loss I need to revise. Okay, so let's see, right? Let's see profit and loss. Okay, and discount and discount. Okay, simple interest might come, Brinda, simple interest might come. Okay, right? Now see this. When we talk about profit, loss and discount, you should know some terms, as we have already discussed in previous classes. The terms that we should know is cost price. First of all, cost price, right? So what is cost price? It's the price at which something is bought, okay? Right, for example, if you go to a shop, right, and if he buy you a pen for 10 rupees, right? Now, that is your cost price or selling price? Tell me, that is a cost price or selling price? We will have class till 1:30 only, 1:30, 1:35. I will just wrap this up so that you can get at least 3-4 hours to revise. Now, that will be either cost price or selling price, okay, depending on whom you're asking for. That's the concept, okay? Means if you're asking for the shopkeeper, right, then that is the selling price for the shopkeeper. Yes or no? Yes or no? Right? But for you, it is a cost price. Okay, everyone? Tell me, okay? So these are the small concepts that you should remember. Okay, so cost price is a price at which anything is bought, and this cost price is for the person who is buying it. Okay, right? Got it? Now, selling price, okay, right? SP is the price at which something is sold by the person, okay? Got it, everyone? Now, we know that if selling price is greater than cost price, then you will have profit or loss. Tell me. If your selling
Profit.
price is greater than cost price, then you will have profit or loss. We will have
Profit.
profit, and profit will be the difference, which is selling price minus cost price. Okay. Now, if selling price is greater than, sorry, if cost price is greater than selling price, right, then you will have loss. You will have loss. And what will be the loss? Loss will be cost price minus selling price. Okay, everyone? Remember? Tell me, remember? Right? Now, after this, we have two more terms, which is profit percentage. Profit percentage. So what is profit percent? Profit percent is profit divided by cost price into 100. Okay, right? This is a profit percent. In the same way, what is loss percent? Loss percent is loss divided by cost price into 100. Now these are the terms which we have to study in profit and loss. Right, everyone? Tell me. Okay. No, it's fine. I was just giving you time. Okay. Right, everyone? Now, we will discuss the last concept, which is the concept of discount. Okay, which was the concept of discount. Now tell me, when you talk about discount, okay, so suppose we have a jeans, right? We have a jeans of 1,000 rupees, right? And people, right, obviously wants to buy, right? Yes, Brinda, that's correct. Profit, again, opposite. Now profit is equal to profit percentage into CP by 100, as simple as that, right? Just cross multiply this now, right? Now, and if the cost of this is 1,000 rupees, and right, we are giving, right, we get, suppose 30% discount, right? Then tell me, what will be the selling price? What will be the selling price of, tell me, what will be the selling price of the jeans, which is Cost price minus discount. Right, everyone? And what is discount? Discount will be discount percentage, right? Discount percent into CP. Got it? Right? Which is, suppose we have D percent discount, so D by 100 into CP. Okay? Okay, everyone? Tell me, right? So if you see this problem, so it will be 30 by 100 into 1000, which is 300. So 300 rupees your discount. So selling price, right, is 1000 rupees minus discount, which is 300 rupees, which is 700 rupees. Okay, so this is the selling price for the shopkeeper. No, Ragini, compound interest will not come. Okay, right, everyone? So I hope all of you understood. Okay. Okay, Devika, 8.3 question number 8. Let's see. Right, let's see comparing quantities. We're talking about comparing quantities, right? So guys, please see. So question number 3 question number 3, right? Now, let's see. Fabina borrows, right? Fabina borrows 12,500 at 12% per annum for 3 years, right? So simple interest. Simple interest is equal to what? Principal, which is 12,500 into. Now rate you should write only per annum. That's one mistake that someone was doing. So 12 into 3 years, time 3 years, divided by 100. This is your simple interest for Fabina. And Radha borrows the same amount for the same time period at 10% per annum, compounded annually. Now, since compound interest is not coming, right? Okay, right? So you can leave this. Okay, but again, compound interest. The formula of compound interest was P bracket 1 plus R by 100 to the power n. Okay, because it is changing every time, right? So this is amount. Okay, right? So compound interest one you can leave for now. Again, compound interest 8.3, we haven't covered all the things, right? Compound interest we still have to cover. Okay, so compound interest will not come. We will take one more class of this. 8.3 is not completed, everyone. Okay, so compound interest will not come. Okay, I'll teach more about compound interest, then we will discuss it. Okay, simple interest, still simple interest only. Okay, everything before simple interest. And see, this compound interest, everything before simple interest will be coming. Okay.
Okay, sir.
Okay, I hope all of you understood everything. So okay, since we have
Okay,
less
sir.
time, okay everyone, so I'll change the timing of test. I'll keep it from 4. Will it be fine?
Sir,